Pulley calculations. I'm going to read you a problem, and then we'll work through it together. A construction crew lifts approximately 600 pounds of material several times during a day from a flatbed truck to a 32-foot rooftop. A block and tackle system with 50 pounds of effort force is, a block and tackle system with 45 pounds of effort force is designed to lift the materials. Now, the Pulley calculations are different than the other simple machines. Well, part of it's different. Actual mechanical advantage is the same. Ideal mechanical advantage, much different. A picture is not required for these types of problems. In fact, it says it's a block and tackle system, but with the information we're given, we don't know how complex this box and tackle is. My understanding of block and tackle is that it's more than one pulley. Exactly how many for this specific problem, there's no way of knowing at this point. So some things that we do that are relevant to a pulley calculation problem is the force of the resistance, the force of the effort, and the number of strands, which we'll call N. Reading through this problem again, it said that the construction crew lifts approximately 600 pounds of material. So the resistance force is 600 pounds. And it says it's 32-foot rooftop. That has no bearing on this problem whatsoever. Distance is not relevant on a pulley system. The block and tackle system uses 45 pounds of effort force. So the effort force is 45 pounds. It makes no mention in the problem the number of strands. So first question related to this problem. Call it question A. What is the required actual mechanical advantage? So it's supposed to find actual mechanical advantage. The actual mechanical advantage is the same as it would be for any simple machine. Take the force of the resistance and divide it by the force of the effort. Resistance is 600 pounds. Effort is 45 pounds. Pounds cancel. 600 divided by 45 is approximately 13.3, repeating. 13.33 to 1 is the actual mechanical advantage. Part B. How many supporting strands will be needed in the pulley system? What this question is actually asking for, what's the ideal mechanical advantage? So it's saying find the number of strands. That's what N is. And that really means to find ideal mechanical advantage. Unlike the other simple machines, which ideal mechanical advantage is distance of the effort divided by distance of the resistance, this is just the number of strands. So IMA equals number of strands. We don't know how many strands there are, but we do know that the actual mechanical advantage is 13.33. What's the minimum number of complete strands you would need to overcome that 13.33? In other words, round the actual mechanical advantage up to the nearest integer. So the IMA here is 14, which is also what N is, because N, number of strands, and ideal mechanical advantage are the same thing. Let's do a second pulley problem. I will read it to you. A block and tackle system with 10 supporting strands is used to lift a metal lathe in a manufacturing facility. A motor being used to wind the cable in the pulley system can provide 75 pounds of force. So what does that tell us? Well, it says that there are 10 supporting strands. So N is 10. It's easy. It also said that the motor being used, the motor is the effort, to wind the cable in the pulley system can provide 75 pounds of force. The effort is 75 pounds. So those are the facts for this problem. Once again, for pulley systems, you do not need to draw a picture unless they give you very specific information, which we're not given here. First question, question A. What is the mechanical advantage of the system? Now we have to assume that this question is asking for the ideal mechanical advantage. We have to assume that because we don't know anything about the force of the resistance, and we would need that to figure out the actual mechanical advantage. Ideal mechanical advantage is equal to N, the number of supporting strands. In this problem, that's 10. So that question is finished. Second question to this problem. What is the maximum weight of the lathe? The lathe is what was being lifted up in this problem. The block and tackle system was pulling up this lathe with 75 pounds of force. So it's asking, part B, doesn't say it, but what it's really asking is for us to find the resistance force. What's the most that lathe could weigh for this to work? So to do this problem, we're going to have to make a poor assumption, but I don't know how else to do it. The poor assumption is that the ideal mechanical advantage is identical to the actual mechanical advantage. I don't think that's true in reality because friction, there's going to be some friction in the pulley system. Ideal doesn't account for friction, actual does. But that being said, the actual mechanical advantage can be found from the formula. The resistance force divided by the effort force. The actual mechanical advantage, if we're saying it's the same as ideal, that's 10. The force of the resistance, we don't know. Force of the effort, 75 pounds. Trying to get the force of the resistance by itself, multiply both sides by 75 pounds. That gives us 750 pounds equals the force of the resistance.